Today I'm going to talk about review materials for test 2. For test 2, we're going to cover section 5.6 to 6.2. Here are the materials that we did in class. So in section 5.6, we study about the fundamental theorem of calculus part 2. In this section, we learned that if you have f of x to be a rate of change function, and capital F of x is the antiderivative function, then you have the definite integral from a to b of f of x dx is equal to capital F of x, which is the antiderivative, right? And then you evaluate this antiderivative between a and b. And by the fundamental theorem of calculus, this is equal to capital F of b minus capital F of a. So basically, this is what you got for fundamental theorem of calculus part 2. In section 5.7, you study about the area between curves. So before, for definite integral, this represents the net area between the curve and the horizontal axis. But now going to section 5.7, we talk about the area of the region between two curves. So suppose you have two curves, f of x and g of x, and f of x is actually greater than or equal to g of x. This represents that f of x is above g of x. And using the information that we got from definite integral, you can write the area between the curve formula as the definite integral from a to b of the top function minus the bottom function. And in this case, I assume that f of x is above g of x. So therefore, you have the definite integral from a to b of f of x minus g of x. In section 5.8, we talk about average value and average rate of change. You have two formulas that you need to memorize. The first one is the average value. If you have a function, f of x, you want to find the average value of this function between x equal to a and x equal to b. Then the formula is the average value equal to the definite equal to 1 over b minus a, multiply with the definite integral from a to b of f of x dx. Now let's move on to average rate of change. So for the formula of average rate of change, you need to find the rate of change function. That is the derivative of f of x. So the formula is So this formula is very similar to what you have for the average value. Instead, the integrand now is no longer f of x but f prime of x to represent the rate of change function. So therefore, this is the name average rate of change. Right? And if you know some information about the original function, you can also use another formula that is f of b minus f of a divided by b minus a. In section 5.9, a lot of people are struggling with the idea of substitution method, and I'm gonna make a video working on a lot of problems related to substitution method. So I just want to say you have the substitution method. And you also have algebraic manipulation. In section 6.1, we start with learning about improper integrals. So as I mentioned, there are three types of improper integrals, but we're just going to address two formula in improper integrals. The first one is the integral from a to positive infinity of f of x dx. And to even tackle this kind of improper integral, you have to rewrite the improper integral into the limit of definite integral. That is the limit as n go to positive infinity of the definite integral from a to capital N of f of x dx. And from here, you can use algebraic manipulation or numerical estimation to solve this limit of definite integral. The second type would be the integral from negative infinity to b of f of x dx. Once again, this is the improper integral, and you should rewrite this using the limit of definite integral. That is the limit as n go to negative infinity of the definite integral from capital N to b of f of x dx. Then you can use numerical estimation and once again algebraic manipulation to get the answer. In section 6.2, we learn about income streams. Using all the integral technique that we learned in 5.6 to 5.9 and 6.1, you can tackle this kind of problem. And there are a few formulas that you need to memorize. One of them is the future value. And the future value of the time period capital T is equal to the definite integral from 0 to t of capital R of t, which is the flow rate, times e to the r times t minus little t dt. And another formula that you need to know is the present value. Capital P is equal to definite integral from 0 to t of R of t times e to the minus little rt dt. So all of this letter should be very obvious to you when you read the problem. And the explanation for this letter should be little r is the interest rate, capital T is the time period, and R of t is the flow rate. So in flow rate, there are three types of flow rate. The first one is the constant flow. The second one is the linear flow. And the last one is the exponential flow. As I mentioned in class, it's not hard to calculate the future value or the present value. The hard part is to identify the flow rate. So you need to read the problem very carefully to identify which flow rate you have. Is that constant flow, is that linear flow, or is that exponential flow? Another problem that usually we make a mistake on is you cannot distinguish between interest rate and the percentage change in the exponential flow. You need to be careful with that.